exercise number 3. It's going to be very similar to exercise number 2, where you're going to do your basic T-joint fillet weld, 2 points, but this time we're going to add weaving to it. Before we do that, I'd like to go over some of the theory or the parameters that we set around a weave so that you understand that. So to get started, basically what we're going to have here is you're going to have your T-joint, your wire going in, your tip in your nozzle. So there's a little diagram of what your weave would look like with the wire in it. There's 2 parameters that you set. Well, there's 3 parameters. 2 parameters that you set are called path offset. Path offset 1, path offset 2. Path offset 1 is the distance here, which is defaulted to 1 millimeter. Path offset 2 is the distance here, which is defaulted to 1 millimeter when you turn weave on. Those parameters will work for a very wide range of welds that you might put in, and travel speeds and other things that we'll get into later that you might set your welding parameters to. So you may not have to change them, but if you do, they can be set individually, which means one of the 1 millimeters could be 2, and you could actually weave 2 millimeters on one side, 1 millimeter on the other side if you wanted to. Let's say you wanted to favor one side or the other, thick or thin material, other nature and other reasons why you might want to do that. But that's what the path offsets are. As your wire is coming in, it's the distance it moves on either side of that wire, that center line of the wire back and forth. All right. The third parameter that you set is called your frequency, okay, in hertz. And the default is 2 hertz, okay? 2 hertz is 2 times per second. It's going to go, if you look at a sine wave as an example, okay, peak to peak on either side. 2 hertz is 2 times per second. Okay, so now, hertz is determined by time. It's a number of times it's going to go peak to peak per second. Okay, the amount of time that's going to determine the number of peak to peaks is a function of your travel speed and distance of your weld. So let's just say you have a fixed weld distance. Your fixed weld distance, P1 and P2, is 10 inches. Okay? If you set a travel speed of 10 inches per minute, okay, it's going to take you 60 seconds, 1 minute, to make that weld. If, as an example, you were to now take your travel speed and go from 10 inches a minute to 20 inches per minute, the time it's going to take to make that weld is going to be 30 seconds. So at 2 hertz, as an example, okay, that's 2 times per second. At 60 seconds, you are going to get 120 back and forth, 2 times per second. Okay. Now, if you double it to 20 inches a minute, not 3 seconds, 30 seconds, and you go down to 30 seconds, you're going to get 60 back and forth for that same distance. So what does that mean? It means, based upon your travel speed, the exact same weld, exactly the same distance, pretend those 2 lines are the same distance. If you're at 10 inches a minute, you're going to get 120 back and forth over that distance. If you change nothing, you don't change your frequency, you don't change anything, all you do is change your travel speed, and you double it from 10 inches a minute to 20 inches a minute, you're going to get half the number of back and forths over that distance. What does all this mean? You don't need to do the math. Okay? What this means is simply this. The slower that you go for a given frequency, the more back and forth you're going to get. The faster that you go, the fewer back and forths that you're going to get. In other words, you want a nice smooth back and forth. You want to make sure that when you're watching that arc, the crater that's being carved out by the arc is being filled up with material as you're going across, nice and flat, and you get this beautiful looking weld when you're done. If all of a sudden you're getting scallopy top and bottom, it's not filling up, whatever, you either need to increase your frequency, you need to increase your wire and put more wire in, or you need to slow down. One of those 3 things, based upon the theory of this, to get that weld to wash out. So, if your welding parameters are great, your travel speed you like, but you're not getting enough back and forth for that distance that you're traveling, increase your frequency. Go from 2 hertz to 3 hertz, 4 hertz, 5 hertz. Okay. Now you don't want to go too fast back and forth, because if you do that, you get an unstable arc. So if you're going back and forth too much for a given distance and travel speed, but you like your parameters, simply lower your frequency number. It's that simple. You don't need to know the math. You can do it by feel. This is where there is math and there is physics with welding, but there's also an art to it. And the art is you begin to be able to see and feel when you have good parameters and good frequencies and good weaves and welds. All right. So let's create a program from scratch, and this time let's weave. All right. See you in a second. All right. Exercise 3: basic T-joint fillet weld with a weave. So we're going to create a new program. Same blue circle icon, part name, exercise number 3. We're going to go next. And so we're going to put in some parameters. Make sure you're not using too thin a material here. These parameters will burn through, but you don't really weave on thinner material. Okay, so make sure you have some thicker material that you're welding on here. And down here you have your radial button for the weave, so we're going to turn that on. Your radial button for the weave. Okay, leave the default parameters, and we're going to say save initial settings. So now we're going to set the foam down, and we're going to add in our points. Add in our first point. Come in here. Add in our second point. Move the robot up. We can save this now. Okay, and we are ready to go. So let's load this into our playlist. So we're going to go exercise 3, create new playlist with this part. Well, I'm going to set the phone down over here so that we don't get spatter or anything on it, because guess what? We're going to dry run it, but then we're going to weld. So with the switch in the off position, we hit play, robot comes in, and now you can see it weaving. Once this is done, we are going to weld. So I am going to put on your proper PPE hardware. We'll do this up. Make sure that you wear your proper PPE when welding, just like you would manually. And we're gonna flip this now to weld, and we're gonna hit play. Alright, so don't want to touch hot parts with bare hands, and we can see we have beautiful welds. Alright, exercise 3 done. See you guys in exercise 4.